Welcome to episode 14 of 100 Days of Data. I'm Jonas, an AI professor, here to explore the foundations of data in AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
It's one thing to predict, another to recommend action.
That's right. Today we're diving into prescriptive analytics, the step beyond just forecasting what might happen to telling you what you should do about it.
So before we jump in, let's set the stage with what prescriptive analytics really means. At its essence, prescriptive analytics takes the insights from descriptive and predictive analytics and combines them with optimization and simulation techniques to recommend actionable decisions.
It's like having a GPS for your business decisions, right? Instead of just knowing where you are or where you might go, it helps you choose the best route.
Exactly. Think of it this way. Descriptive analytics tells you what happened, like looking in the rearview mirror. Predictive analytics helps you anticipate what might happen ahead, kind of like seeing the road signs up ahead. But prescriptive analytics suggests the exact maneuver to take, whether to speed up, slow down, or take a detour.
And that exact maneuver bit is key for businesses struggling with complex choices. For example, in supply chain management, it's great to know forecasted demand, but prescriptive analytics helps decide how much inventory to hold, where to ship products from, or when to expedite orders, balancing cost and service.
Well said. Historically, prescriptive analytics has roots in operations research and decision science fields that emerged in the mid-20th century with mathematical models to optimize resource allocation.
Yeah, industries like manufacturing and logistics led the charge back then. They needed systematic ways to decide how to use limited resources efficiently, especially after World War II.
Right. Over time, the explosion of available data, increased computing power, and advanced AI models have propelled prescriptive analytics beyond just mathematical optimization into simulations that model complex systems and machine learning that can handle more uncertainty.
And that's where the magic happens in the real world. Take healthcare, for example. Prescriptive analytics can help hospitals decide the best staffing schedules while considering patient inflow predictions, staff availability, and even regulations. It's not just a guess. It's an informed recommendation balancing multiple objectives.
That brings us to three core components that often power prescriptive analytics: optimization, simulation, and decision-making frameworks. Let's unpack those briefly.
Please do. Sometimes those terms get tossed around, but practical clarity helps.
Optimization is about finding the best solution out of many possible choices, aiming to maximize or minimize objectives. For instance, minimizing delivery cost or maximizing production output while respecting constraints, like budget, time, or resource limits.
So in retail, an example might be optimizing product pricing to maximize revenue without driving customers away.
Precisely. Then simulation involves creating a model that mimics real-world processes to test different scenarios without risking real assets. This is especially useful when the environment is too complex or uncertain for purely mathematical optimization.
I've seen simulation used in manufacturing plants. You can simulate a production line to identify bottlenecks or test process improvements before making physical changes.
Correct. Lastly, decision-making frameworks balance multiple objectives or uncertain outcomes. Techniques like Markov decision processes or reinforcement learning help systems make a series of decisions, adapting based on what happens next.
It's like a chess game, thinking several moves ahead, but updating your plan as your opponent reacts.
Perfect analogy. And prescriptive analytics often uses these frameworks combined with real-time data to continuously adjust recommendations.
I love how this frames data-driven recommendations not as static answers, but as adaptive guidance. But Jonas, what about the challenges? Implementing prescriptive analytics sounds great, but I know from the field it's not always straightforward.
That's an important point. Prescriptive analytics depends heavily on data quality and the accuracy of the underlying models. Poor data can lead to recommendations that might be worse than guesswork.
I've seen companies invest heavily in analytics tools, but overlook data cleanliness or fail to integrate systems properly. Then the recommendations feel disconnected from reality and get ignored by decision makers.
Exactly. Another challenge is complexity. Optimization and simulation models can be mathematically sophisticated, and without clear communication, business users may mistrust or misunderstand the insights.
Which is why involving stakeholders early and translating outputs to understandable language is vital. Otherwise, you risk developing black box solutions that don't gain adoption.
There's also the issue of computational resources. Some prescriptive models, especially simulations with many variables, require significant computing power or time.
Cloud computing and modern AI platforms are helping with that. But you're right, sometimes decisions need to be fast. For example, financial trading algorithms must act immediately, which shifts how prescriptive analytics is applied.
That's a great lead into practical applications. Amy, could you share some industries where prescriptive analytics is making a big impact today?
Absolutely. In automotive, prescriptive analytics helps with predictive maintenance and inventory management. For example, manufacturers analyze sensor data from cars on the road to recommend when parts should be replaced before failure, optimizing maintenance schedules and reducing downtime.
That combines both prediction and prescription nicely.
In retail, personalized promotions increasingly rely on prescriptive analytics. It's not just predicting what customers might like, but recommending which offer to send to each individual at the right time to maximize conversion and profitability.
Healthcare is another big one, as you mentioned earlier.
For sure, scheduling surgeries, staff rostering, and even treatment plans benefit from prescriptive models that balance many constraints: patient needs, resource availability, and cost.
Finance firms harness prescriptive analytics for portfolio management, balancing risk and return by continuously recommending asset allocations based on market data and client goals.
And supply chains are probably one of the biggest beneficiaries overall. Anything from deciding shipment routes to inventory placement across warehouses, balancing speed, cost, and resilience to disruptions.
Amy, do you think prescriptive analytics will eventually be a core capability in all businesses?
I do, but with a caveat. It has to be accessible. Tools need to become more usable by non-experts, and companies must cultivate a culture that trusts data-driven recommendations while keeping human judgment central.
Well put. Prescriptive analytics doesn't replace humans. It empowers them with better information to make smarter decisions.
Exactly. And sometimes nudging human decision makers towards an action is just as important as proposing the optimal answer.
Before we wrap up, let's summarize our key takeaway.
I'll start. Prescriptive analytics is about moving from knowing and guessing to recommending. The deliberate use of optimization, simulation, and decision frameworks to guide actions that improve outcomes.
And I'd add that its power lies not just in the models themselves, but in how well these insights are integrated with human decision-making and operational realities.
Up next on 100 Days of Data, we'll explore exploratory data analysis, the essential first step for understanding any data set before making predictions or prescriptions.
If you're enjoying this, please like or rate us 5 stars in your podcast app. It really helps us reach more curious minds. And don't hesitate to leave questions or comments. We might feature them in future episodes.
Until tomorrow, stay curious, stay data-driven.